Now for K, remember that we are defining K with respect to frame one, because that's what because the matrix basically B was defined with respect to frame one. So it's K in one. Now, in order to find the relationship between, and to answer the geometric relationship between A and B, we must basically relate what is K basically in frame zero. Okay, so we know that K in frame one is this one. Okay, if we would like to calculate K in frame zero, the representation of K in frame zero, we basically pre-multiply it by the rotation matrix that takes a vector in frame one and project it in frame zero, okay, which is R1 to 0, which is nothing but rotation about the y-axis, okay, by 30 degrees. And we found that this matrix from before is this one. And if you multiply it with this, you will find necessarily that this is going to be 0, 0, 1. So what is K? What is K in frame zero? Basically, it's the z-axis in frame zero. Now think about it, okay? The K in frame zero is the z-axis, and theta is 30. So we are rotating. A is nothing but a rotation about 30, rotation about the z-axis by 30 degrees, and K is aligned to that 30. So basically, what you can think of K is nothing but a vector that is basically parallel or aligned to this vector here. Okay, so it is coincident. So this is my K here. Okay. So basically, if you basically rotate by 30 degrees about K, it is going to be similar to rotation about the z-axis in frame in the selected frame, of course. If you select frame 0, then you rotate about the z-axis. If you select frame 1, then you rotate about the k-axis, and they will both do the same thing to rotated objects. Okay. Hope this is clear. Let me stop here.